Folks, this is a question for the first half. You're probably just going to need one piece of notebook paper. And yeah, if you want to just do this on the back, that'd be okay too. So our essential question.
Yes.
Yeah, 6-6. Folks, the essential question, can I solve radical equations and equations with rational exponents? We can keep in mind we can change. Ashley, come over. Let's just do it, but you can hold this for that. Come on. Actually, no, it's like holding you. Keep in mind, I can solve radical equations. I can change radical equations to rational exponents and vice versa, right? I can go back and forth between the two. So, guys, there's steps, and these are not like, you know, when we talked about graphing polynomials last time and some other things, you know, I gave you. I can say this. What even the difference between there and there? Come on. I gave you like the steps A, B, C, D, and I said, please do all 4 of these steps, do them in order. This is not like that. These are 4 helpful steps. You'll do one of these, you may do all of them, but like these are just some good steps. So one good thing that will help you is to isolate the radical, because usually my variable that I'm solving for is going to be under a radical, so you're going to do that anyways, right? So most of the time you'll do that, but isolate, nothing that might help. Raise each side to a power, okay? And that can get rid of radicals, obviously. And again, most of the time you're going to do that. Because you'll want to actually have a number and solve, unless it's an irrational number without a variable under it, you're going to get rid of that radical. Most of the time, okay? And then here's the nice bit. Knowledge has a W, that's ironic. Solve using your previous knowledge. Everything we talked about in terms of algebra stays the same. And actually, most of it's pretty simple. Looking at all these equations, here you're going to go, well, those are much simpler than all the polynomials we've been dealing with. Okay. So some of these I'll do all of them, some I'll do some of the steps, right? This first one, solve and check, and we'll talk about checking. Okay. So my first step was what? Isolate the radical. Well, I've got a variable in the radical there, so I'm definitely going to have to get rid of it. And then I'll have, so let's do that. First step to solving this, guys. 2. Divide by 2, right? I want to get rid of this on both sides. Okay, leaving me with the cube root of x minus 3 equals 2. 4 divided by 2 is 2. So now I've isolated my radical. Step 1, right? Now what's left? I need to get rid of that radical, right? I need that x by itself. So I am going to raise each side to a power. What power is that? Cubed, right? So this whole guy is going to get cubed. This whole guy is going to get cubed. Leaving me with x minus 3 equals, and what is 2 cubed? 8. And then solve using previous knowledge. Gee, I wonder what I do to this in order to solve. What? 11. Oh, I was like, it's not 2. We need to work on your previous knowledge, right? So add 3 to both sides. X equals 11. Folks, here's where checking your answers come in. This is, I don't know if this is a new rule for you or not. Have you ever heard of extraneous solutions? When do extraneous solutions occur?
What's our formula? Sure. I'm sorry.
Well, so an extraneous solution is a solution that I get, and here I've got a solution of 11. But when I plug it in and it doesn't actually solve, right? So, but when do I have to check for extraneous solutions? It's not actually, well, for us it's going to wind up being a lot, but it's only in one instance. Think about this, guys. When you square root something, you take the root, you get a plus or minus, right? Because you can have two answers. Think about working the other way. Anytime you square, water, that funny? Anytime you square or cube or raise a side, or both sides, if you do both sides, to a power, that's when you can check for extraneous solutions. So think about it like the opposite of taking the square root. Square root, I get plus or minus. Anytime I square or cube a side, I have to check for extraneous solution. So I'm going to check this 11 to see if it works. So we're going to plug 11 in, and I'm fine if you do this on your calculator. On your test, quiz, homework, everything, in terms of checking answers, once you get your answers, box them, and then if they don't work, just scratch it out, say not a solution, and put like a check mark by the ones, or just don't scratch out. So let's check this. Plug in 11. What is 11 minus 3? 8, okay. What is the cube root of 8? 2. So then 2 times 2 is 4. So does this solution work? Yes, you can put a little check mark, you can write solution, yay, plus next to it or something. Just make it clear that it works and that you checked it. I need to know that you checked them. And if you didn't check, I'll know because you're giving the answers that don't work. So, any radicals in this one in B? Not explicitly, but I do have a rational exponent, the 1/2 power, which is like taking a square root, right? So you could rewrite this as the square root, you wouldn't write this little 2, right, of x plus 25 equals 4, and then what would you do from there? I'd square each side, or I can skip that whole step and just straight up square each side, right? This becomes x plus 25 to the 1/2 power, and I'm going to square that, which equals 4 squared. And so what happens to my exponents? It's canceled. They become 1, right? Leaving me to adjust. X plus 25 equals 16. At x plus 25 to the 1/2 power. Instead of rewriting that as a radical square root and then squaring, get rid of that square root, I can do the same thing. I can just square it like this, and 1/2 times 2 is 1. I can just stay. So x equals 16 minus 25, -9. Good. Now we need to check that. So we still need to check, right? I've still squared both sides. So plug it in. What's -9 plus 25? 16. And then 16 to the 1/2 is the same as the square root of 16, which is 4. So this answer of -9 absolutely works. Nope. X minus 4 to the 2/3 power minus 9 equals 16. Lucky, what do I need to do first here?
You need to square both sides.
Is that what I want to do first? So I'm going to take this and square it, this whole thing. That's what you want to do, Lucky?
By 3.
By what?
Cube it.
You want to cube both sides?
Yes, please.
Lucky, what if I got rid of 9? Well, what if before that I put my phone away and didn't pull it out of their class?
I'm sorry.
Yeah.
I'm missing a presentation right now.
The AP Psych one?
Yeah.
Why? Well, Lucky was trying to tell us is we should add 9 to both sides, right? Right? No, 2/3. Oh, sorry. Yeah, I know this would be hard to see. If you need me to say it or write it bigger, I will. We good? So then, how do I get rid of this 2/3?
You the other side by
I mean, I could cube. Cube would work because if I multiply this by 3, I would get 6/3, which I can change to square. So I would essentially be squaring both sides. Or how can I make this 2/3 just become a 1?
reciprocal.
Reciprocal. So if I raise each power to each side to the reciprocal, okay. So I'm going to raise this to the 3/2 power and this over the 3/2 power. This guy just goes away. So x minus 4 equals 25. And you're going, just moves that 3/2 over there. It's not that much better. Well, it's not actually that bad, right? Let's rewrite it. It's 25 cubed and the square root of the whole thing, right? Not 253. Which is a lot better. I think it is. We could. What's 25 cubed? 625. That helps. Just think 5 times 5 is, or sorry, yeah, 5 times 5 is, 5 cubed is not 625, it's 125.
That's what I said.
No, it's 25 cubed. You know what it was? What's 25 cubed? No,
No.
Oh, it's like,
it's a big number.
here.
It's what?
15,625.
625? Good. Good. So what's the square root of that? What is it? 125. Here's where things get different, okay? Not different, actually, just what you're used to doing. This isn't, square root of 15,625 isn't 125. Well, it is. What else is it? Plus or minus. So, guys, the way you know, well, how do I know whether to do plus or minus or not? When there's an equal sign, when we're dealing with equations, I want plus or minus, okay? Because I want to know actual solutions. When we're just evaluating, when we're just simplifying, no, you don't need to. It won't hurt, but you don't need to. But equations, equal sign, always square roots become plus or minus. So then I'm going to add 4 to both 100, negative 125, and to a positive. So positive 125 plus 4 is 129. Negative 125 plus 4 is negative 121. Do I need to check those answers? Yes, you do it. Plug them in your calculator, or if do it in your head, that's fine too. Plug each of those in. Tell me what you get, if they work, right? Whatever you plug in, don't forget this minus 9 should equal 16. Like 2, I'm going to check either, or scratch one out, or scratch them both. This is good practice for writing exponents, right? Raised to the 2/3, because I don't know how to do that. When you hit the up arrow like you do for anything else, it then just makes some parentheses 2 divided by 3. Your calculator takes that. What do we get? The 129 is good? Alright, awesome. Check the negative 121. Although, I guess, negative 121? Try negative. I think it was 2, but I'll confirm. Make sure I didn't mess up either. I've got 2, it does. It does? Awesome. They both work. No. I check them. You might wait to box them, like so you get these solutions right, and then go, hold on, let's check, and then only box the ones that work. Or, and honestly, what I do, you know, I box them. I don't check it. If one of them didn't work, I would go. You don't need to check this. But this does work. So for those of you watching at home, x does equal negative 120.